Today we will discuss the CBSE 2019 Physics Board paper. So let's start with the first question. Plot a graph of de Broglie wavelength associated with electron as a function of its kinetic energy. So for this, the graph would be, so this is the de Broglie wavelength, and here this is the kinetic energy, and this would be the graph. Second question, identify the equivalent gate for the circuit of a combination of gates shown in the figure and write its symbol. So here, if this is A, we get A bar, and here B bar, so that if these two gates which is connected with the NAND gate will give the output A bar into B bar whole bar, which is equivalent to A plus B, which is our OR gate. And what would be the symbol for the OR gate? That would be this. So if this is P and Q, this is our output Y. Or draw the logic symbol of the gate shown by the combination of gates and write its name. So as these two are the NOT gates, we get A bar and B bar. As this is passing through NOR gate, we get A bar plus B bar whole bar, which is equivalent to A dot B. We can prove this also by drawing the truth table, which is optional. So if you want to calculate whether I am getting A dot B or not, just draw the truth table on the rough page. Or you can get this by using the Boolean algebraic expression. So as this is the AND gate, so the symbol would be this. If this is the input, we get the output Y, which is P into Q. Write one important property of a paramagnetic material. Paramagnets do not retain magnetization in the absence of a magnetic field because thermal energy randomizes electron spin orientations. Or you can write another property, which is they have a small positive susceptibility to magnetic fields. Apart from that, they have been given so many properties in your textbook, you can refer that also. Or, do the diamagnetic substances have resultant magnetic moment in the atom in the absence of external magnetic field? No, they do not retain the magnetic properties or moment when the external magnetic field is removed. Question number 4. Why can the interior of a conductor have no excess charge in the static situation? The answer is, if a conductor is placed in the external electric field, say E, the force due to E is F is equal to QE. Due to this force, the negative ions move and gather at the one side of the conductor, that is in the direction opposite to E. So on the other side of the conductor, only positive ion remains. When the force of internal electric field and the external electric field are equal, they cancel out each other since they are in opposite directions. Thus, a static charge distribution occurs and there is no excess charge inside the conductor. Fifth, when a PN junction diode is forward biased, how will its barrier potential be affected? As we know, the potential barrier in the PN junction is the barrier which does not allow charge flow across the junction normally. This resistance to the flow of charge is called potential barrier. So when the PN junction diode is forward biased, the barrier potential reduces to 0, and above that, if we provide the more voltage, or you can say above the knee voltage, the current starts increasing to its saturation value. But for this question, you just simply have to write that the barrier potential will be reduced. when it is connected across the forward biased condition. Section B. Question number 6. Draw a block diagram of a generalized communication system and write the functions of the transmitter and receiver. So the block diagram would be, the first is the information source, which gives the message signal to the transmitter, which is passing through the communication channel, which is received by the receiver, and that message signal is given to the user. We can write the noise also across the communication channel. The function of transmitter, it is an arrangement which processes the incoming message signal so as to make it suitable for transmission through a channel and subsequent reception. Receiver, it extracts the desired message signal from the received signal at the channel output. Next question. Question number 7. Obtain the conditions under which an electron does not suffer any deflection while passing through a magnetic field. As we know that the formula for finding out the magnetic force when a charged particle Q moves with the speed of v in the presence of magnetic field B at some angle theta is F is equal to QVB sine theta. So the condition when the electron does not suffer any deflection while passing through the magnetic field is, either you take theta as 0 degree or 180 degree, means if the electron moves either at an angle of 0 degree or 180 degree to the direction of magnetic field, that will not suffer any deflection. Second part. Two protons P and Q moving with the same speed pass through the magnetic fields B1 and B2 respectively at right angles to the field directions. If the magnitude of B2 is greater than B1, which of the two protons will describe the circular path of smaller radius? Explain. As we know that F is QVB sine theta and theta is 90 degree as it is given. This is equal to mv square by r. So here v and v gets cancelled, so that we get QB is equal to mv by r. Now the two protons moving with the same speed, so Q is same for the protons, B we have to see, R also we have to see, but mass m and v speed is constant for the two protons. That means we can say that B is inversely proportional to R. As B2 is greater than B1, this implies R2 is less than R1. That means Q, that proton will describe the circular path of smaller radius. So answer is Q. Question number 8. Two coils P and Q of radius R and 2R are lying in the same plane with their centers coinciding. Find the magnitude and direction of the resultant magnetic field at the common center if they respectively carry currents 3I and 2I in opposite directions. So here, according to the question, two circles are given. So two circular coils are given having radius R and 2R, where the current 3I and 2I is flowing in the opposite direction. So say if this is P coil, this one is Q. So for P first, say the magnetic field is B1, which is, now you know the general formula for finding out the magnetic field, which is mu naught I upon 2R. So B1 would be mu naught I is 3I upon 2, R is capital R, and the direction by using right hand thumb rule, we get the magnetic field in the outward direction and write the unit Tesla. For Q, the magnetic field would be in the downward direction V2. So here mu naught, the current is 2I upon 2, radius is 2R. So that this can be written as mu naught I upon 2R Tesla. Let's suppose the outward direction I am taking as positive and inward as taking as negative. So we can write the net magnetic field as plus B1 because we have the B1 in the outward direction, minus B2 because we have the B2 in the downward direction. So B1 is 3 mu naught I upon 2R minus B2 is mu naught I upon 2R. After solving this, we get 2R as an LCM, 3 mu naught I minus mu naught I, which is 2 mu naught I upon 2R, which is mu naught I upon R Tesla. So here, as you can see, this is coming positive and we have taken the positive as the outward direction. So our net direction would be in the outward. Next, the ninth question. A wire of resistance R, length L and uniform area of cross section A is stretched till its length becomes double. It is then cut into 3 pieces of equal length which are connected in parallel. Find the net resistance of the combination in terms of resistance capital R. So according to the question, a wire of resistance R having length L and the uniform area of cross section A is given. So we can write R as rho L by A. Now this wire is stretched to double its length so that the length becomes 2L and the area becomes A by 2. So say now the net resistance is R dash, which is rho L dash upon A dash. L dash is 2L and A dash has now become A by 2, so that this can be written as 4 rho L by A, which is 4R. Now this wire is cut into 3 pieces of equal length. It means this R dash 4R is divided into 3 equal parts. We can write this as 4R by 3. Now these 3 resistances are connected in parallel as per the question. So here 4R by 3, that is connected in parallel. So now the net equivalent resistance would be 1 upon 4R by 3. So that we get 9 upon 4R, or we can write 4R by 9. So the net equivalent resistance is 4R by 9. Question number 10. Derive an expression for the torque acting on an electric dipole of dipole moment P vector placed in a uniform electric field E vector. Write the direction along which the torque acts. So this is the direct derivation for the torque experienced by the dipole in the presence of uniform electric field. So say the electric field is given in this direction where the dipole is placed at some angle theta. So here from minus to plus, P vector is given where the electric field is making an angle of theta. So let's suppose if this is P, this one is Q and this one is R. If this angle is theta, this would also be theta. So the force experienced by minus Q would be minus QE and this would be plus QE. Now let's find the torque The basic formula for finding out the torque is force into perpendicular distance. The force which is coupled in this case is QE, because the equal and opposite force is acting, which is QE, into the perpendicular distance of this force is PR. Either you take this force or you take this force, you get the perpendicular distance PR. Now how to get PR? Take the triangle PRQ, find sine theta, which is PR upon PQ. Say PQ is 2A. So we can write PR upon 2A, that is sine theta. So PR can be written as 2A sine theta. So if you replace this value over here, you get torque QE into 2A sine theta. Now Q into 2A is PE sine theta. Or if we write in the vector form, we write it as torque vector is equal to P vector across E vector. And how we can find the direction? By using right hand thumb rule. Or derive an expression for the electric field at a point on the axis of an electric dipole of dipole moment P vector. Also write its expression when the distance r is very much greater than the length a of the dipole. So this is the expression where the dipole is placed at 2 points, say A and B, and C is the center of the dipole, and P is the point where +1 coulomb the test charge is placed, where we have to find the electric field which is kept at a distance r. So for B, the electric field at P due to B in the outward direction, and for A, electric field at P due to A is in the opposite direction. Now EPA is 1 by 4 pi epsilon naught Q upon PA square, which is K. Let's write 1 upon 4 pi epsilon naught as K, Q upon PA, which is R plus A whole square. Similarly, electric field at P due to B is 1 by 4 pi epsilon naught Q upon PB whole square, which is KQ upon PB is R minus A whole square. Now since EPB is greater than EPA, so the net electric field would be EPB minus EPA. So EPB is KQ upon R minus A square minus KQ upon R plus A square, so that after taking LCM we get R plus A square minus R minus A square, so that if you solve this and open the bracket, you get 4AR, which can further be written as 2KQ 2A into R upon R square minus A square whole square. Now what is Q into 2A? That is P, which is a dipole moment. So 2KPR upon R square minus A square whole square. So this is the net electric field on the axial line. Now the case when the distance R is very much greater than A, so since they have asked to write the expression only, so the expression would be 2Kp upon RQ, because in that we replace A with 0 because R is very much greater than A. So after solving this, we get 2Kp upon RQ. Question number 11. The figure shows a network of the 3 capacitors connected across a battery of 10 volt If the charge of 6 microcoulomb is acquired by the capacitor C3, calculate the charge acquired by C1. So let's write the values. C1 is 2 microfarad, C2 is 6 microfarad, and C3 is given as 3 microfarad. Charge of 6 microcoulomb is acquired by the capacitor. So here the charge across third capacitor is 6 microcoulomb. Now for the third capacitor, if we apply the formula Q is equal to CV, Q is 6 microcoulomb, C is 3 microfarad into V. So from this we get V as 2 volt. That means the potential drop across the capacitor is 2 volt. So for C2 it will also be 2 volt because they both are connected in parallel, and in the parallel we have the same potential difference. Now the battery of 10 volt is connected across the arrangement, so that will be 8 volt. So that 8 plus 2 will give you 10. Now apply the same formula again. Q is equal to CV. C is 2 microfarad and the potential drop is 8, so that you get 16 microcoulomb. Next question. The frequencies of two side bands in an amplitude modulated wave are 640 kHz and 660 kHz respectively. That means the lower side band, which is omega c minus omega m, is given as 640 kHz, and the upper side band frequency is omega c plus omega m, which is 660 kHz. Find the frequencies of the carrier and the modulating signal, and also obtain the value of bandwidth required in amplitude modulation. So if we solve this, we get 2 omega c, that is 1300 kilohertz. So that omega c is coming 650 kilohertz. So this is the frequency for the carrier wave. And similarly we can find the frequency for the modulating wave. After putting this value in any of the equation, we get 10 kilohertz. So that if you add you get 660, and if you subtract you get 640. The second part, the value of the bandwidth, which is twice of omega m. So 2 into 10 kilohertz, which will give us 20 kilohertz. Or a sinusoidal carrier voltage is amplitude modulated by a sinusoidal voltage of 10 kilohertz with modulation index 0.3. If the carrier frequency is 10 megahertz and its amplitude is 40 volt, calculate the frequency and the amplitude of two side bands. Now here omega c is given as 10 megahertz, omega m is given as 10 kilohertz, which can be written as 0.01 megahertz, and amplitude of the carrier wave is 40 volt, and mu is given as 0.3. Now as mu is AM by AC and mu is given as 0.3, so we can write AM as 0.3 into AC, which is 40. That will give us 12 volt. So here amplitude of the modulating signal is 12 volt. Now the frequency of the two side bands, so the lower side band is omega c minus omega m, which is 10 minus 0.01 megahertz, which will give 9.99 megahertz, and the upper side band, so omega c plus omega m, which is 10 plus 0.01, which is 10.01 megahertz. We will discuss the solution for the section C and section D in our next video. Thank you.